Okay, we're looking at higher derivatives. Okay, let the Colorado pot jokes begin. Yeah, I know, funny, right? Okay, everything, okay, let's focus here. Everything we've been doing is the first derivative. We're going to start doing second, third, fourth derivatives and more. So this is a f triple prime at -1 is the third derivative. Third derivative.
The derivative of the derivative of the derivative.
Yeah, pretty much. So f triple prime -1.
Why? What is this? No.
Oh, we'll get there, Ben. We're just doing the formal math right now. Okay, so what is f prime at x of that?
No.
Okay, what's f? You with me? Us, you with us, I guess I should say. What's f double prime? Derivative of that.
What? I'm so confused. Oh, did you multiply this 2 by 4?
Okay, we're using the power rule to find the derivative. And then from here, we take the derivative of this to get the second derivative. And then now do the third.
Oh.
And then now plug -1 into the third derivative. Okay, so we have 180, and then this one is 180 plus 168. What if I have, okay, are we good? We've used the power rule repeatedly, until we're sick of it.
What if we have to do a little bit definition for this? No. From the board.
That's you saying.
Will we have to do a little bit definition for this?
What's the worst
Okay.
prime you've ever seen? Like how many?
What if we have something like this? It's a product rule. Okay, it's going to get nasty, but you've got to keep going. This is an evil, sadistic math teacher way of making you practice your power rule and your product rule. Okay, so what's f prime of x? The product rule. So what's the derivative of the first? There's the rule. So we take the derivative 1, copy, plus, copy, derivative. See how this is going to expand fairly quickly? F double prime. Okay, that's just the derivative of e to the x. But now we have another product rule here. If we did the third,
Is
Okay.
that 1 times the x?
yeah, 1 times e to the x.
Oh, because of the constant,
Derivative is 1,
or the
copy the second,
variable, okay.
plus copy derivative. Okay, can you see how this is going to expand pretty quickly? Can you imagine doing a quotient rule problem?
Fun.
You have a twisted version of fun. Okay. You get the idea of higher powers. He.
Oh, so you're using the product rule?
Yep. So this product rule, 1, 2. Then this one is a product, so 1, 2.
Yeah,
Okay.
okay. Where does 3 1 start? 3 1 4?
Here's where the rubber meets the road, so to speak, with acceleration. If I give you a position function, we learned f prime gave us what? Velocity. Guess what f double prime gives us? Okay, because we have rate of change of position, and then the rate of change of velocity is acceleration. Okay. Nothing we really worry about. Okay. Okay, so here's an example. Find the acceleration of a ball tossed vertically in the air from ground level at 12 meters per second. Okay, Galileo's formula for position oh, that should be a minus. Okay, and it's in meters. No, you don't. What's S0? That's initial position. What's my initial position? 0. Initial velocity. Okay. So now we have our function. How many derivatives do we need? So S prime at t, which we also know is velocity of time. Right? Take the derivative. And then the second derivative is acceleration. It's the derivative of velocity. We also call it a of t. Okay, what number did we
So it's
get?
always like an 8?
What is the acceleration due to gravity?
That is, yeah.
Yeah, 9.8 meters per second squared. That tells us it's a falling object. That's why it's negative. Pretty neat, right?
That's so cool.
Amazing how that really falls out. So the acceleration of a ball tossed vertically in the air is always, you're decreasing 9.8 meters per second squared.
What if you're finding the acceleration for when it goes up into its maximum?
It's still negative 9.8 because it's slowing down by 9.8 meters per second.
Oh, that's pretty cool.
Makes physics. It makes physics look really neat.
Well, I mean,
Okay, if that is the ball tossed in the air, what does the graph of the derivative look like? What's the value of the derivative right here? Okay, to the left here, it's positive, getting smaller, right? The slopes are getting smaller. So, and then here, something like that, right? Something. It's a sketch. And then we know the slope of the acceleration, so the second derivative is actually going to be down here somewhere. It's a constant. Yeah, somewhat. It's at negative 9.8. Okay. So that relationship will probably be on the AP test in a free response format as a particle motion problem. No, sketch that. Will be on the AP test. Okay. So this is free money right here. 3 points. You get this down, you got 9 points on the AP test. Bam, right there on a free response. Okay. Any questions? None whatsoever. Okay, let's see. The homework does seem kind of long. It's 3.5. I'm going to start chopping the prelims with number 4.
I don't like big long colors that say this, and gravity. Gravity.
How many of you are in physics right now? Anybody else that's okay? It's a very fun class.
I don't like going to I don't like putting out with it. It's like, why would I have to predict? The only time I have to predict movement is like if I were strong or something, and I'm like, I have to be your thing more than
Holy smokes, I'm on the wrong. Scratch that. I'm on the wrong line. Okay, I'm reading the wrong one, so bear with me here. Okay, yeah, lots of work there. That came from my brain.